All right, so we're going to do section 7.3, and once again they're warning us that about if you're given three sides, because this section is going to be the section where there's three sides could be possibly given to you, and on 319 they're saying make sure that the length of any two of the sides is greater than the other side, because that could be a possibility that would make it that there are no triangles that fit that. Now, the situation where we have side, included angle, and a side, or three sides, that situation requires the law of sines. They develop the law of sines for you on the bottom page 19 and the top of 320. So I guess I'm not going to go through that. You can look at it to see what it is, but the law of sines for when you're given side angle side or three sides, you will have to use one of those three equations. And notice it's always whatever side that you're trying to calculate, or whatever formula you're trying to use, it involves all the sides. You know, if it's a squared equals, then it's b squared plus c squared minus 2bc cosine of a. And whatever is that, you can look at it, see how to figure out how the system works, but you will have those as a resource if you bring that handout that I gave you. So you won't have to try to remember those formulas. And then the page 322, the two cases that are going to be in this section. It says when you have two sides and an included angle. Notice that's different than case 2 where you have two sides and a not included angle. So when the angle's included, notice that second step. The first step says you're going to have to use the law of cosines to find the third side. Then that second step says find the smaller of the two remaining angles. So you will have step number 1, you'll have calculated all three sides. And now you look at all three sides, and if you do the smaller angle, what is that angle going to be opposite? The smaller side, right? So that's what you have to look for. Is you look for the smallest length, and then you calculate the side opposite that, the angle opposite that side. Now, as opposed to case 4, when you have all three sides given to you, now you see the step is find the largest angle. If you don't do those, step 2 in case 3 or step 1 in case 4, there are situations where you can have difficulty. So you be sure and have this available when you're working those out, especially on the test, and follow those steps so that you don't get yourself in trouble. And then that Heron's area formula is a way of calculating the area when you're given all three sides. So what we'll do is we'll look at some problems there on 7.3 exercises. Okay. On 9 and 10 it says find the length of the remaining side of each triangle. So notice that that's two sides and an included angle, correct? That's what you're given. So number 10, and I'm going to actually letter it so that you can. All right, if we say this is angle A, B, C, and it does not make any difference, then this is going to be B, and this is going to be C. And what they're giving us is they're giving us this angle, which is 60. And they're giving us this side, which is 3, and this side, which is 8. You can letter it any way you want. Now, if you do the side, then the formula you're going to use is A squared equals B squared plus C squared minus 2AC sine of A. That's, if you look back, you have the three choices, and if you're going to find A, then it's got to be that one. Yeah, sorry, thank you. I'd have gotten there, figured that out. Cosine. So, but you see that on this side it involves only A and C, and then the angle A. So if we substitute in here, A squared equals, and you can do some shortcuts here, 3 squared plus 8 squared minus 2 times 3 times 8 cosine of 60.
How do you put 3 and we don't know what
A is this, that's what we don't know.
Yeah, but the formula is 2AC, you have minus 2 times 3.
No, when we have B squared, C squared, it's 2 BC. I put B in, but
I'm asking if
yeah.
you had A written.
Yeah, I know it, but I did put B in. Yeah. Okay. But this side is going to involve only these values. So then the A is going to be the square root of this, and it's going to be the positive square root. And it's going to be 9 plus 64 minus 48. And cosine of 60 is what? But we know it, don't we?
Off the top of my head, half.
Yeah, it's 1/2, yeah. So we have 73 minus 24. And what's that, the square root of 9, 49, which is 7. So, yeah, you're gonna use the positive square root. That's why I put the positive square root, and at least I did that much right. So the next one says do not use a calculator, and they want to have that angle theta. So what we do, 12, let's try and draw something. I guess this is, it isn't going to look quite right, but this is 1 and 1, right? In the square root of 3. And what they want is this angle. Well, it's pretty arbitrary, but what you should do in order to be able to figure out how you're gonna set it up is give yourself some values. Like I'm gonna let this be A, then this would be small a. And now it's arbitrary. If I go B here, this is gonna be little b. If I go C here, this is little c. Now we have a frame of reference. So what we want to do is the formula we want to do is the one that involves A in the cosine, and that's going to be the one that has A squared up front, right? And then what you're going to have to do is find the cosine, get cosine A by itself. So what I'm going to do is I'm going to do this in an algebraic fashion. I'm going to put 2BC cosine A equals B squared plus C squared minus A squared. I'm just going to get that A by itself. So then I have to go cosine A is B squared plus C squared minus A squared over 2BC. And what I'll do is I'll go ahead and I'll calculate this, make sure that that comes out to be a positive, a number that's calculatable. So at this point, I'm just going to put values in. And notice that the A and B are 1, and the C is the square root of 3. So B is 1 squared plus square root of 3 squared minus 1 squared over 2 times 1 times the square root of 3. I don't want to quite it once. It is 1 2 times the square root of 3. So this is 3 over 2 square root of 3. Now I don't have to rationalize the denominator. I guess I could, because if we did this, if we rationalize this, we could do it without the calculator, right? We rationalize this denominator. And this becomes 3 square root of 3 over 2 times 3, and the 3's cancel. So this is the square root of 3 over 2. Cosine of A is that. So we can say A has got to equal what? Where is it? Square root of 3 over 2. 30 degrees. So that would be our answer.
Can you go up for a second? Okay, did you just sort of subtract from either side of equal sign?
Yeah, I moved the A squared over here by subtracting. See what I did was this. I subtracted A squared. And then I added 2BC cosine of A to both sides.
It's one, okay. It's one piece. I guess I would have added 2BC and then subtracted cosine A. That wouldn't necessarily. It's one piece.
Yeah, you got, this has got to be one term.
Okay.
You have to do it term by term.
Okay.
You can't, because they're multiplied together. And that's called a term, so you have to add and subtract terms. Terms are things that are multiplied together.
The rest makes sense now.
Okay. Okay. All right. I think what we'll do is we'll just go ahead and we'll look at some of those problems on the next page where they're just listed out. And what I'm going to do, because the way I'm going to present the problem is I'm going to have, you're going to have to find all of these values. These are the ones you get. 4.21. 4.21 is 5.71 C. And what I would suggest is that you would say, all right, this is two sides and included angle, right? You have to make sure you identify that. Then you'd say this is case 3, and the first step says find the third side in that little sheet that you have, right? You know where I'm talking about. Okay, so you identify that it's two sides and an included angle. See, if it were either B or A as the angle, then it would be case 2. This is case 3. Then in case 3, then you go over to step 1. It says find the third side. So the formula you're going to use is C squared equals A squared plus B squared minus 2AB cosine of C. And then you substitute in. And then what I usually do is I just say, all right, I'm going to use the positive square root and put my numbers in. So A is going to be 4.21 squared plus 5.71 squared minus 2 times 4.21, 5.71, and then cosine 28.3 degrees. And then run your calculations out. Let's see in this thing. This one's plus. Oh, rats. I know already that this, but I'm not going to have, I forgot to set this up in degree mode. Okay. Is that what you got? 2.83. So now that on that case 3, what's it say? It says find the smaller of the two remaining angles using the law of sines. So this one. So the two remaining angles. So which one of these two is the smaller? A is. So what we want to do is the law of sines, so we'll do the sine of A and we're using over A, but if I multiply it, can I do that? Is that too much of a shortcut?
Just like the last unit, right?
Yeah,
Okay.
it's sine of A over A, but I'm just multiplying up here.
Right, yeah.
Yeah, and then I didn't put, I should put this C. And notice we're having to use a calculated value, because this technically, we're going to have some error, because this is really a calculated value. But when you're using case 3 and 4, you're just going to have to accept that error, because it's a round-off error, because it's really 2.82779 something. Unless we use it and keep pulling that thing in, then we can get accurate. Now, what I'm going to do is I am not going to do sine inverse of this. I'm going to plug the values in and then make sure that I have it and not get into the trouble of, like we do in that case where there isn't, where it's larger than 1, the sine of A. This is C, 2.83. So if we want to increase our accuracy when we're doing this, then what we would do is we go 4.21 times the sine 28.3 divided by, and then I would go up. If I wanted to increase my accuracy, I'd use that number. And then, now then, that is going to be what the sine of A is. So, and that will have a angle because it's less than 1. So now I'm ready to go second sine inverse of that number. And I have 44, and I probably have to go 44.9. Now what I want to do is I want to calculate A, and I can calculate A by doing the 180 degrees minus the sum of those two. Oh yeah. All right, B is what I want then. 44.9. So I go plus 44.9. Plus 0.8. Is it it's 106, right? 106.8. So we don't have to use the law of sines to do this last one, because we can just use that subtraction. And that's what the find the remaining angle using the angle sum formula. So we'll look at 24. Notice this is 3 sides. Eight, 37, 58. Now, if you look at the sheet, it says what? Find the largest angle using the law of cosines. So, which one are we going to use? C, right? So we're gonna use the formula then that says C squared equals A squared plus B squared minus 2AB cosine of C. And then we have to get that cosine C by itself. So once again, we're going to do this 2AB cosine C A squared plus B squared C squared. And the one thing we didn't check is you always want to make sure that any two sides, the sum of it is larger than the third side. And it is. So you don't have a situation when you don't have a triangle. So what I'm going to do is I'm going to go ahead and do the C equals cosine inverse of this deal up here. And I'll put those values in, I guess. 28 squared plus 47 squared minus 58 squared. 2 times 28 . Whoops, today do. Minus 58. Oh crap. I get a double bracket this thing. Otherwise it'll just divide that 58 squared by the next. Bracket, then divide, and then bracket 2 times 28 times 47. Bracket and bracket. That should do it, shouldn't it? Yeah. But if you don't put it, in, then it'll just divide 2 into 58 squared. And then multiply the rest of that and sum them otherwise. So, I mean, if you don't put it in right, and so we got 98 degrees. And this one was C. Now, if you look in there, it says use the law of sines to find the remaining. So it does not make any difference at this point which one you use. You don't have to, you just pick another one of these and use the law of sines to calculate it. So if I wanted to do B, I would do sine B is equal to B, and then I'm going to have to use this ratio, sine of C over C. So B is going to be 47 times the sine 98.1 over C is 58. Sine. Now, I don't have to worry about brackets because I'm multiplying. See, before I had to worry about brackets because I was doing what? I was adding in that numerator. So then you have to bracket it. Otherwise it's a garbage in, garbage out situation, right? Divided by 58. Now then, that qualifies because it's a number between 0 and 1. So now I'm going to do this sine inverse. Okay, dang it. And I got 53.3, and that was B. So this is and now we can find A by just subtracting, right? $27.6, is that right? Is that what everybody got? I don't know. 4 from 0, 1, you have to borrow 1, so you're borrowing 7, then borrowing 1 from here, that makes that 9. You take 180 minus 152. 28.6. 6 and 4 is 10. 1 to carry is 10. Oh, you didn't tell me that this was wrong. But that's 4, 8, and 3, okay. And it's 28. Okay. So it's 28.6. All right. I guess you want to look at any of these other ones? If it's
Well, it seems okay, and I'm following along. It's
okay.
Similar to what we were doing
All right.
last year.
What I'm going to tell you is that you better follow this set of steps, because if you don't follow the steps, that's where you're going to get in trouble. Is it, you have to make sure you're in case 1, case 2, case 3 or 4, and then do step 1, 2, and 3. And if you don't do that, find the smaller angle. When you're in case 3, find the smaller angle, and you do the larger angle, you get yourself in a situation possibly where you get the wrong angle. And once you get the smaller, because you'll get in a situation where you have what you think is 2 triangles, and it's not possible. And then in case 4, if you don't do step 1, then you get also in trouble. And I can do one of those ones with that Heroin's formula for area. If you notice the formula, let's see this up. Yeah, I got it here. It's on your sheet. So if we look at 66, 8 is 22, 45, and C equals 31. Now notice the first thing you have to calculate is this value S, which is 1/2 of that sum, 22 plus 45 plus 31. So if I did it right, S is 49. Then the area is going to be the square root of, and it's S times S minus A times S minus B times S minus C. $49 minus 22, 49 minus 45, and 49 minus 31. $49, 27 times 4 times, that was 31, wasn't it? And that's 18. Did you get it? This 49 comes out as a 7. 27 comes out as a 3 with a 3 left under. 4 comes out as a 2. That's number 3 comes out, and that's square root of 6, isn't it? I don't know.
Right, 308, 36.
Whatever those numbers are.
I just put them all anyway, yours, behind, there's nothing to it. Can we just do it in the calculator? Or do you
Yep,
want-
yep, I was just killing time.
I got you, okay. As long as that works.
All right, so, because you guys can put it in the calculator faster than I can. There's a few things that you should be wary of. And that's, remember when I calculated this, that you bracket that thing. You know, there's just things that, mechanical things when you're putting in the calculator. Remember that you got to bracket this when you put that division in. And then you could probably get by without bracketing this. I think you better bracket this whole thing to make sure that whole thing is in the denominator. No, it would divide it by, what it would do is it divide the bracketed item by 2 and then multiply the results by these 2. I mean, you got to think about what you're telling the calculator to do. And there's those kinds of things that are going to create problems in your answer. So you got to make sure that you know how the machine works, the way it's thinking, and then you got to, then my suggestion is you faithfully use this little sheet to identify, first of all, which case you're in. If you wrongly identify the case, you're going to approach the problem. And then you follow those steps and do it faithfully. If you do it, then the chances of success are pretty good. In case 2, when you have the 2 possible triangles, it's going to be pretty long. So, otherwise, methodology is not that hard a set of problems. Just all right. I'm not gonna do vectors and dot products. That's something that you'll just have to, if you go on into calculus, you'll just have to pick it up there. And what I'm going to do Friday, I'll come in and I'll pick up the last of your papers. And then if you have questions about anything that's going to be on the final, I can tell you what the final is going to be. I just want to shut this thing off.